think we can get started here. Share my screen. Hi, everyone. Welcome to the Ballerina Community Call. Thank you so much for joining us today. Before we get started with the technical sessions, I wanted to kind of take you through how you can get involved with the Ballerina community and kind of engage with us a bit more. So there's a few ways that you can engage with the Ballerina community. And I'll be sending this repo link to you via the chats, either the YouTube chat or the Zoom chat right after I stop speaking. So you have all these links available to you as well. So a few of the ways that you can engage with the Ballerina community. First of all, we have a Slack channel that you can join, and our development team is super active on it. So if you have any questions or if you want to have any discussions regarding Ballerina, you can join our Slack channel and ask away. For questions, we also have the Google group and Stack Overflow. So Google group is mostly for development discussions. And if you have any questions, you can also ask them on Stack Overflow and tag Ballerina like this. Next, we have our Twitter channel. Do follow us on Twitter at Ballerina Lang. So there we kind of give updates on product updates, language updates, like when releases happen, and even events and community calls and any kind of content that we publish and things like that. So do give us a follow there. We also have a monthly newsletter that we send out usually at the end of each month, where we curate a whole bunch of content around topics like cloud native applications, integration, microservices, things like that. So we curate that content and we send it straight to your inbox. So if that's something you're interested in, you can subscribe to our newsletter through this link as well. And of course, we have the community calls. So we usually try to do them every month, every last Tuesday of the month. Sometimes this date might change. So if you do want to be informed of these calls and kind of keep track, just fill in this form. There's a link to a form where you can fill in to be notified of the calls. So basically, if you are on that list, we'll directly add you to the calendar invite, so you won't miss any of the calls moving forward. And also, if you do want to get involved in the call itself, if you want to maybe if you created something cool with Ballerina and you want to give a quick demo of it, or if you want to suggest any topic that we should be covering, there's another form here that you can fill to send in your suggestions as well, and we'll be happy to consider them for our future calls. Next, how can you contribute to the actual Ballerina community? So there's a whole bunch of different ways. First, you can write content. So we have a Ballerina tech blog on Medium, which is run by the community, by community writers. So if you do have any piece of content that is published on Medium, do send it over to us and we will get it published on that tech blog. You can also write to other publications like vZone, InfoQ, and things like that. You can also record and publish any video content around features in Ballerina or anything cool that you've created around Ballerina as well. You can also speak at meetups, conferences, and any other external events, and even host your own meetups and hackathons or any community-driven event for your local community. And if you do want to do this, do give us a shout. We will be happy to help you get started with like resources and things like that. You can also contribute to the language directly. So you can report issues, you can build and publish a module on Ballerina Central, and you can even contribute directly to the source code as well. And do go over to our GitHub repo, Ballerina Lang, and give us a star and follow as well. So if you have contributed in any of these ways, you can. There's a form here that you can fill. We'd love to kind of get to know what you have done with Ballerina and kind of help you promote any of the content that you have published as well. So that's it about how you can kind of engage and contribute to the Ballerina community. So I'm gonna, so just before we get started, a few things. This video is gonna be recorded and it'll be up on our Ballerina Lang YouTube channel. And we'll also be posting the recording on our Twitter account as well. So you can get the link there as well. And also, if you have any questions, do ask them. If you're on YouTube Live, you can ask them on the chat at any time. If you're on the Zoom call, you can ask it on the chat anytime. But we do encourage you at the end of the session to kind of unmute yourself and ask any questions that you have from the team, and kind of get like a very open discussion going at the end of the session. So hope we can get that going after we have the technical sessions over. So yeah, that is basically it from me. Today we have Tisuru and Dimuthu, who will be talking about GraphQL and Ballerina. Sorry. Yeah, and how it's a match made in heaven. So yeah, that's it from me. Over to you, Dimuthu. Thanks so much.
Yeah, thank you, Sam. So let me share my screen. Hopefully you can see my screen. So hello everyone, hope you are doing well. So I'm Dimuthu. Currently I'm working as a software engineer at WSO2 Ballerina team. So this is the lineup for today's session. First we will give a introduction to GraphQL, then we will be talking about GraphQL in Ballerina, and then our future plans. So before we start the session, I have a special announcement to you guys. Some of the features that we are covering today are not included in the currently released Ballerina version. So these features are coming with our next release, which will be releasing probably in the next week. So that if you want to try out these features today, you can download the pack via the links. We have included the links in invitation and the description of the YouTube stream. So, okay, let's get started. So, what is GraphQL? Actually, GraphQL is a well-known concept with related to APIs. According to the definition, GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. So, simply we can introduce GraphQL as a data query and manipulation language for APIs. So GraphQL is an open source data query and manipulation language, which is developed by Facebook. And now it has moved to GraphQL Foundation. And there are a large number of GraphQL users in the world. So Facebook, GitHub, and Shopify are some well-known platforms that are used in GraphQL. So when it comes to the data representation in GraphQL, so the data in GraphQL represent data in graph manner. So it defines structures for the data, and it resolves some problems which we faced in REST APIs. So the most common problem we are facing with REST APIs are overfetching and underfetching. So what is overfetching? Let's say you want to access a single field of data through REST API. So then if you send a request, sometimes it returns a complete JSON object with many other fields. So then you have to process that JSON object and get particular field. So this is called overfetching. Fetch the data more than what we want. So when it comes in underfetching, so in some cases we have sent multiple requests to different API endpoints. So to fetch the data that we need. So that is called underfetching. We can't get all the data via a single endpoint. So when it comes to GraphQL, it overcomes these issues. So if we send a query to the GraphQL server, we will get exactly what we ask, nothing more and nothing less. So there are no overfetching and underfetching issues in GraphQL. So, and other than that, GraphQL represent data in graph manner, as I mentioned in earlier. We can send requests as a queries, and it always returns predictable results. And one other special thing is GraphQL carries access not just the properties of one resource, but also it smoothly follow the references between them. And these are some advantages in GraphQL. There are a few other things that we should know about GraphQL. So actually GraphQL is a query language. It's not a programming language. So GraphQL does not mandate a programming language to implement a GraphQL server. So user can use any language that support GraphQL to implement a GraphQL service. And there are many languages that support GraphQL. Also, you can choose Ballerina as your language to implement a GraphQL service. So it's very easy to implement a GraphQL service with Ballerina. If you want to try, if you want, you can try it yourself with our demo today. So, okay, how to write a GraphQL service? So when it comes to GraphQL, there are two main approaches to implement a GraphQL service. So first one is the schema first approach. So in schema first approach, what we do is we first define the schema for the GraphQL service. Then we implement the code according to the schema. So when it comes to code first approach, we first define the resolvers. Not the schema, we first define the resolvers, and then from the code as a single source of truth, schema is generated automatically. So both approaches have a schema, but instead of being manually created, it's created automatically in code first approach. So most of the languages that support for GraphQL included one of the methods. When it comes to Ballerina GraphQL, it uses this code first approach to create a GraphQL service. So you don't have to worry about the schema writing with the Ballerina. So actually these both approaches have pros and cons. And we are not going to talk about pros and cons today. So moving on. So I think it's better to continue with some Ballerina GraphQL examples. So I handed over the session to Tisaru to continue the session with demo. Over to you, Tisaru.
Thank you, Dev. Let me share my screen first. Hope you guys can see my screen and hear me clearly. As Dimtu mentioned, now we are going to talk about how to write services in GraphQL services in Ballerina. In this session, we call our title was GraphQL and Ballerina, the match made in heaven. We say this because there are many matching parts between GraphQL and Ballerina, which are like a match made in heaven. Let me go through a list of these similarities and matches first, and then we are going through the demo. You can understand why we are calling this match made in heaven. So the first things first, GraphQL, ultimately GraphQL is a service, and services are first-class citizens in Ballerina language. As most of you guys already know, GraphQL, Ballerina is a language designed for network programming. So services are first-class by design. So in Ballerina, when you write a service, it's quite simple. And in Ballerina services, you have support for hierarchical services. When it comes to GraphQL, GraphQL is a language defined hierarchically, so that they can define and present data in a tree-like manner. And Ballerina also have hierarchical services so that we can define services in a tree-like manner. And as Ballerina is a network programming language, we have first-class support for handling data. And obviously, GraphQL is also trying to handle data. And we also, Ballerina also have support for concurrent services within given limitations. So if you implement a service which can be concurrently executed, then Ballerina language will handle that. So you don't have to worry about concurrency and stuff. And When it comes to type systems, GraphQL type system and Ballerina type systems are quite similar, and there are a lot of similarities in them. One thing to notice is union types. GraphQL have union types. You can define union types in GraphQL schema. And in Ballerina language, you have by default support for union types. You don't have to like add any annotation or somewhat workarounds to support union types. We have it in the language. And as we said, Ballerina is designed for data. So we have nil value support, and GraphQL has null. Both these types are quite similar. And when it comes to GraphQL, there are two different object types. In GraphQL, they call it input objects and output objects, and mostly output objects are called just objects, and input objects are called input objects. And in Ballerina, we can map these to input objects to Ballerina records and output objects to Ballerina objects. This is quite interesting case, because in GraphQL also, when you consider output objects, they are not just objects with values in fields. We call them resolvers. So we can map those resolvers into Ballerina object functions, and that's something interesting. And then in GraphQL, we have a concept called default arguments, default values for arguments. So in GraphQL resolvers, we can include any number of arguments, and they can have default values. And in Ballerina function arguments, we also have default values built within the language. You don't have to use any other workaround to define default values. And also, Ballerina is strictly typed language, so we have compile time type validations. And when you write GraphQL services in Ballerina, your types are compile time validated, so you don't have to worry about some unnecessary runtime errors. And also, we have support for structural equivalency, which will be pretty much easier when you talk about GraphQL clients, because you don't have to like create separate types for different occasions. And so, yeah, these are the main things we want to highlight with the similarities between GraphQL and Ballerina. And let's walk through our demo and find out. So first of all, we want to know how to write GraphQL services in Ballerina. Ballerina, as I mentioned earlier, Ballerina provides native support for services as first-class citizens. So if you have any prior experience with Ballerina services, like writing a simple HTTP service in Ballerina, so GraphQL service is no different. They are pretty much the same thing. And as Dimuthu mentioned, you don't have to provide a schema first. When you write the service, that service will become the schema, and GraphQL Ballerina engine will generate the schema for you. Okay, so let's go into writing the services. And first of all, when you want to write a service, you have to create a listener first, and you have to have a GraphQL listener to attach your GraphQL service. There are two main ways to create a GraphQL listener. First way is to create using just the port number. Let's say you want to create a GraphQL service using in port number 9000. You can just create a listener like this or like this. This one is actually a syntactic sugar for the first thing, and it will create and attach a service to this listener as well. So in our demo, I'll use this notation mostly, but keep in mind that these two are pretty much the same. And then we have another method to create a GraphQL listener, which is creating an HTTP listener first, and then pass that HTTP listener into the initial parameters of the construct of the GraphQL listener. This is quite quite an advanced case. This comes handy when let's say you want to create an HTTP service and a GraphQL service on the same port. So you can create an HTTP listener like this using the port number you want, and then you can create a GraphQL listener by passing this HTTP listener as the construct parameter. That way, you can attach an HTTP listener to this HTTP listener, HTTP service to this HTTP listener, and then you can attach a GraphQL service to this GraphQL listener. So the both services can serve on the same port number. And there are some additional configs similar to HTTP listener configs. If you have any experience, you can go through our documentation and find out more about these additional configurations. But for the sake of this demo, I'm not going to add those additional configs. I'm going to just use these simple service definitions. So, okay, then we are going to define a service. Now we know how to define a listener, but now we have to write a service. So in GraphQL, each and every GraphQL schema must have a root query type. There can be three main root types in a GraphQL schema. Those are query, mutation, and subscription. The mutation and subscription types are optional, but the query type is a must. So you must define a query root type. And in Ballerina, you don't have to do anything unusual there. You just have to write resource functions as you write in any other services. And those resource functions inside the root GraphQL service will become fields of the root query type. So in GraphQL, these query operations are meant to be executed in parallel. They call it, they have no side effects. So what this means is when you execute a query, you don't change anything to the underlying data source. So that way, if you execute a query, you don't change anything at the backend, you just read them. In that sense, we call it no side effects. And let's go into a simple example and then check out how this happens. And I'm going to write a simple hello world service in Ballerina. I have a new Ballerina project here. I'm just going to delete this and import Ballerina GraphQL package. So if you use VS Code, it's pretty much easy to write Ballerina codes. We have a pretty good VS Code plugin. And first, you have to write this keyword service, which means you are going to write a service, and then you have to provide a path here. This path is the place where we host our service. You can either keep it, either remove it completely, then it will be served at the base or the root, or otherwise we can give a path here like this. So I'm going to give it as GraphQL, and then I'm going to define the listener where we serve our service. So I'm going to create a new GraphQL listener here, and I'm going to provide the port number, and this is our service. And as I mentioned, we must define query root type. That means inside a Ballerina GraphQL service, you must define a resource function. So I'm going to define a resource function here. And for this resource function accessor, we have to put get keyword. This get means you are not going to change anything. You are only going to read something. And let's say I'm going to create a greeting, and this will return a string. And I'm going to return hello world. Okay, so this is it. This is the simplest form of a GraphQL service you can write in Ballerina. And I'm going to run this. And for this demo, I'm going to use GraphQL Playground as it's a beautiful and nice client written for tryout GraphQL endpoints. So I'm going to put my link here. We have localhost 9000, and this is the path we mentioned there. Here. So this path is the one where we host the GraphQL service, and I'm going to connect to that. Okay, now if we check our schema here, this GraphQL Playground provides a nice and easy way to check our schema here. And we have our schema. As I mentioned, we have our query type. This is a must in a schema, and this query type has one field and its type is string. So this is the hello world program we wrote, and I can query it using this simple query. This is the shorthand notation for GraphQL queries. You can always add query keyword here, but by default, if you do not add any keyword there, it will take it as a query. So if I send this, we get this hello world response. So in GraphQL, you always get a JSON as a response, and it will contain the data we asked for. Okay, so that's the hello world program for Ballerina GraphQL. And let's say we have to have an input for this program. In that case, I'm going to add an input here, and I'm going to return the greeting with the name, and I'm going to run this. I have to close this and open it again because this client is not reloading its schema correctly for some issue. I don't know. Okay, so now if we check this, our schema is updated. We have an input for this field, which is a string. And if we send our existing query, it will give an error for you because this field must have an argument. So what I have to do is I have to add an argument here. Let's say Ballerina. Now it will send our response. So that's how we can use inputs in GraphQL services. And then in GraphQL, we have a concept called non-null values and nullable values. So this value can be null. So let's say I'm going to get this as a null value, and I'm going to use type guard here. So what I'm doing is I'm asking for an input, but it can be null. User can opt to not to send this variable. So if it is an string, you can return that customized hello greeting. Otherwise, we just send the hello world simply. And I'm going to run this. Let me open that again. Okay, so now if we check, previously you might remember that there was non-null value here, and now it is nullable. That means we can either pass this or we can either not send it at all. If I send this one, we get that customized response. Otherwise, we just get our hello world response. Okay. So that's about nullable values, and we also can have default values as well. As I mentioned earlier, GraphQL has a concept called default values, and I'm going to show you something here. Let's say ballerina, and now the thing here is this one. Sorry about that. Now what we do is we have a default value here, which means you don't have to provide it. If you don't provide a value, it will return to the default value. Now I'm going to run this again, and connect to our endpoint. Now, if you check, we have our schema, and then if I send this, we get our default value, hello ballerina, and I can always send a value for this. Let's say, okay. So yeah, that's how you can handle default values. And up to now, we only talked about scalar values. Scalar values are in GraphQL, we call scalar values int, string, float, boolean, and kind of things. So GraphQL represents data as a tree-like manner, as I mentioned earlier. In this tree, all the leaf values are represented using these scalar values. But for do something useful, you just cannot rely on only on scalar types. You have to define object types. Object types are the ones in these intermediate levels. So GraphQL have this object type for this, and there are two main object types as we mentioned, input types and output types. Let's see some similarities here. So if you want to define an input object in GraphQL, this is the way to go. You define an input and you provide the name, and then you mention the fields of this object. And in Ballerina, it's pretty much the same. You define a type, and this is a record type in Ballerina, and you define the fields of that object. And sorry, and you can see the similarities here, and also here we have two non-null fields and one nullable fields, and here we have the same functionality in Ballerina as well. Then we can move on to service objects, and these are used to define object types in Ballerina, specifically output objects. And these types can have null, and nullable values as well. And as I mentioned, each GraphQL field inside a GraphQL output object is not necessarily just a value, but it can be a function, and it can have some calculations and processing as well. And to handle this, we use Ballerina service classes to define output objects in GraphQL. So let's see an example. So I'm going to define a service class here. Let's say person, let's say student. This will be helpful for later. I'm going to define two private variables here, ID and name, And I'm going to define an init function, and it will have two inputs. And I'm going to just assign these values. And as we said earlier, each resource function will be a field of the object type. So now we are going to define a student object type, and if we want to define fields of this object, we have to define resource functions inside this. So let's say I want to get the name of the student and ID of the student. So I'm going to define a resource function here. This name will return a string, and we are going to return self.name. Sorry about that. And I'm going to define another resource function, ID. This will return. Okay. Now what we have to do is we have to define a resource function here, because this is the root GraphQL service, and this will be used to generate our GraphQL schema. And if you don't include this class inside this service anywhere, or any middle point, you don't get this into your schema. So we are going to create the resource function here, and I'm going to say this get profile maybe, and this returns us. So one thing to notice here is we get compilation errors here already, because you must return a data type inside a GraphQL from a GraphQL resource function, and it's a compiler time validation. So I'm going to return student here, and let's say I'm going to return, sorry, let's say, oops, I have to provide an ID first, and our student's name is Jesse Pinkman, and I'm going to run this again, and also close this and open it again. Now, if we check our schema, we have a new type here called student. And this student have two fields as we defined, name and ID. And also in our query type, we have a new field called profile, and its type is student. So now we can request for this field, and sorry, profile does not have any fields, but as we mentioned, GraphQL is data query language, and you get what you request, and you cannot request an object like this. This will give an error, because you have to request exactly what you need, which means you have to provide the structure of data up to a scalar value. So here you cannot just request the whole object, you have to provide a field. And let's say I want to get the name of this person, and here we get this data. And if you request ID as well, then it will provide you with the ID. Yeah, so that's how you can define objects in GraphQL Ballerina. And then we can look into union types, and this is pretty much similar if you see. So in GraphQL, this is how we are defining union type, and this is how you define a union type in Ballerina. Just a simple difference. So I'm going to show you how we can do this. Let's say I'm going to create another object here. And let's say it's teacher, and I have another field here. Subject, and so now this teacher object has an additional field called subject, and I'm going to define a resource function to get this value. This will be a string, and we are going to return self dot subject. Okay, now now we have two types here, and we have to define a union type. So it's pretty simple. We are going to define type, let's say person, and person is a union of student and teacher. Okay, so that's it. We have defined a union type in Ballerina. So now I'm going to create another resource function here. Let's say get people, and I'm going to return a person array here. So this is another way to show how we can return an array in GraphQL. So GraphQL supports an array of types, but in that case also you have to request each and every field you want, and that filtering process will be applied to each and every item in the array. So I'm going to create, I'm going to return an array simply. Let's say I'm going to add new event here, ID number 1. Pinkman. And okay, so here we have another error, compile error. This is because if you write, if you want to define union types, you have to define them as distinct service classes. This is because in Ballerina we have structural equivalency, and we have to make sure that this class type is the type we named. So we have to use distinct here and here as well. Okay, now we can return this. Oops. And I'm going to add another entry here. Let's say Walter White, and subject is chemistry. Okay, so this is our array, and we are going to return an array of person types, and we call it people. And I'm going to run this now. Okay, now if we check our schema, here we have our union type, and we have our student type and teacher type and our query type as well. So now if we want to query this, we have to use GraphQL fragments. I'll explain why. Let's say I want to get people, and since both these types have name field, we should be able to request the name, right? But you cannot, because if you return a union type, you must provide fragments, and you must tell on which type you are going to do this. because union types can or cannot have similar fields. So in this case, I'm going to define a fragment first. This is how you provide a fragment. Let's say student fragment on student. And for student, I just want to get his name. And I'm going to define another fragment called teacher fragment on teacher. And I'm going to get his name and subject too. And on people, I'm going to use this student fragment and also teacher fragment. What this means is people will return an array of person, and if this value is a student type, it will apply this student fragment here, which is the name only. And if you get the teacher type, it will apply this fragment. And let's check it out. And if you send this, you get the data. The first item in the list is a student type, so it will only give the name field as we asked here. And the second element is a teacher object, and we get what we asked for. Let's say I want to remove the name field here, and it will only show you the fields you only asked. So yeah, that's how you define union types in Ballerina. And there's also another concept in Ballerina, we call it hierarchical paths. And sorry, so what in hierarchical paths, what we do is since GraphQL represents data in a hierarchical manner, we can define the same data structure inside a GraphQL service using these hierarchical paths. So when you define a hierarchical resource paths, Ballerina GraphQL engine will automatically create types and fields for you. Let's say let's see this example. In this example, we have a GraphQL service, and in this service, we have a bunch of resource functions. And as we mentioned, we create the schema using these resource functions. And what we do is we get this hierarchical path set up, and we create all the intermediate levels as separate types. So now, if you create this service, there will be a single field called profile inside the root query type. And this profile will have three fields called name, age, and address. And this address field also have the type of this address field will be also address, and it will have two separate fields. Let's try this out. I'm going to clean this up. And this too, and I'm going to write a resource function here. Right. And I'm going to add another resource function with the age. And I'm going to add another resource function address and number. Another resource function here. File address city. Okay, so this is our service with hierarchical resource paths, and I'm going to run this. What's this? Okay. Now, if we check our schema, we have a single field in the query type, and it is profile, and it has the same named type here. And the profile type has 3 fields, as we mentioned: address, name, and age. And address field has a type of address, and it has 2 fields. So this is what we define in our service. And I can try ask profile, but it is an object and you cannot get that. You can but request its name, and also you can ask for the city as well. Here we get the data we requested. So this is an interesting way to represent data, because this is pretty much similar how GraphQL maps data, and how you can do just the same in Ballerina as well. So that's that. And up to now we only talked about GraphQL queries, and we also have another concept called GraphQL mutations. I told you earlier, in a GraphQL schema there are 3 main root types, and those are query, mutation, and subscription. So what GraphQL mutation does is it is expected that a GraphQL mutation can have a side effect. What this means is each and every GraphQL request is used to request data from a server. And if you do a query, you just ask for data. And if you do a mutation, that is expected that during this mutation, you are going to do some changes in the underlying data source. So that's why we call it having side effects, because we have requested data, but while requesting data, we are doing some changes to the data source as well. So since these mutations can have side effects, we don't parallelly execute mutations as we do in queries. These executions are done serially. That means inside a mutation, if you have fields A, B, and C, these fields will be executed as they are in the order. So we defined query type fields using resource functions, and we now have a mutation type. And to add fields to mutation type, we use remote functions. Let's see how we can define a mutation inside a GraphQL service. I'm going to clean this up, and so I'm going to create a resource function here first, because if you remember, I said that each and every GraphQL schema must have to have a query type. So I'm going to add a simple greeting here. And then I'm going to add a remote function. Let's say update something. Okay. So to do this, we have to define an object first, and let's use our previous example. Let's say service class, and we have name and city, and I'm going to define an init function to initialize this. And I have to define two resource functions to get these values as well. Just going to copy this and paste it here. Okay, and also I'm going to write two functions to update these values. And I'm going to copy this. City. Okay, now we have a service class where we can update fields as well. And now I'm going to define this remote function to person. And what I'm going to do is first I'm going to create a person here, and inside the init function, I'm going to initialize this. Let's say right, and let's get rid of this for now. And what I'm going to do is return this self.person. And since remote functions are by default public functions, we have to define this as a public class. Okay, now we have update function, and I'm going to update this name as well. And let's just copy this and use to update the city as well. And I'm just going to add another resource function just for the sake of it. Okay, so this is our service, and I'm going to run that. Let's close this now and open it again. Okay, now if we check our schema here, we have mutation type as well. So we have the query type, which has only a single field of person, and then we have our mutation type, which have two fields, update city and update name. Then we have our person type. So let's first check how we can get the data here. This is a simple query. Now I'm going to do a mutation. So in this mutation, what I'm going to do is I'm first going to update the name. Let's say Mr. Lambert. And this update name will return the person object, and I'm going to get the name and the city as well. And Since I want to use it again and again, I'm going to define a fragment here. I want name and city. Okay, now I'm using that fragment here, and then after that I'm going to update the city as well. Say Hampshire. And I'm also going to use the same fragment here. Now if we send this, we can check that first they update the name to Ms. Lambert and the city remains the same, and then we update the city. We have the updated name already, and then we get the updated city as well. So this is why we said these are executed serially, and once we process this one, then we are going to execute this one. That way we don't run into any race conditions and all in GraphQL service. So that's about mutations, and we also have introspection support in GraphQL services as well. So GraphQL in GraphQL spec they define introspection, and GraphQL service must support introspection to check the schema itself, and you can use any of these fields to introspect about a particular schema. Let's say I'm going to introspect this schema, and I want to get the types of the schema, but this type is also an object. I want to get the names of each type. So if I send this, we get this long list of type names. These types starting with underscore underscore are reserved types for GraphQL schema itself, and other than those types, we have our query type and strings, mutation, boolean, person, and all. So that is how you can use introspection in Ballerina GraphQL as well. All these things you can do while just defining this service itself. You don't have to provide a schema or any other thing. So that's it for GraphQL demo, and I'd like to hand this over to Dimuthu again to talk about our future plans. Thank you.
Yeah, thank you, Tisar. Let me share my screen first. So, okay. So we are going to add some exciting features to Ballerina GraphQL in the future. So first we have subscription support. So in the GraphQL, there are three major operations: query, mutation, and subscription. Currently, we just provide only the query and mutation support. So in the near future, we are going to add the subscription support. So, and then as I mentioned earlier, this GraphQL Ballerina used the code first approach. So here we have to create the resolvers first. So in the future, we are going to add the schema first approach. You can create the schema and then write the resolvers. So this is some long-term plan. So then we are going to add a GraphQL client, which is make it easier to access the GraphQL endpoints and the data loader. So data loader kind of a mechanism that reduce the amount of requests that are going to the GraphQL servers. So we are going to add that too. So guys, this is the end of this session, and thank you for joining everyone. So if you have a question, you can ask now.
Dimitra, I think there's a question in the Zoom chat from Ricardo.
As we mentioned, GraphQL has three main operation types. Those are query, mutation, and subscription. So in subscription, what we do is you can subscribe to a GraphQL service, and service will be feeding you details in a stream-like manner. So currently, you cannot use GraphQL subscriptions using Ballerina. That's why we mentioned that we are going to add that support.
Okay, there are now questions on YouTube as well. So I think we can wrap up for today. Thank you so much, Tisaru and Dimitra, for doing the session today. And again, thanks everyone for joining. If you do have any questions later on, even do join our Slack channel, and then you can ask your questions then. The team will get back to you then. And the next community call will be next month, so the last Tuesday of next month. So I hope we can see you there as well. Thanks, everyone. Bye.